but here we are at the Crisler Center where we've done beautiful things in these past few weeks. So the University of Michigan continues to revolutionize how we do almost everything in the world. And I'm super excited to present our first demonstration of the day because I'm just as curious as you guys are. This is our keynote demonstration, Scientific Discovery in the Age of Decentralized Agents. This is Karthik Durasamy, Professor of Aerospace Engineering, Director of Michigan Institute of Computational Discovery and Engineering, and his partner, Fiona Wang, PhD student of Biological Engineering at MIT.
Thank you. I think this is supposed to come up. All right, great, thank you. So as Dave and Dan mentioned, so the OpenClaw Foundation and the University of Michigan are partnering to create the Institute for Agentic Computing, right? So what does this institute do? That is obviously the core work of developing OpenClaw and keeping it open source and helping people from all over the world build applications on top of it, right? So the idea is, this will advance not just agentic computing, but scientific discovery, engineering, and the broader knowledge economy. So while the Institute will be developing the core infrastructure and extending applications to many disciplines, we also want you to think about it as a portal to the entire agentic world, right? So along these lines, we're happy to announce a list of founding affiliates, the University of Chicago, MIT, and Fiona's gonna present a couple of things in a couple of minutes, and Rescale, which is a unicorn with a University of Michigan founder, and they're leaders in high-performance computing. All right, so give me a minute and a half before, Fiona, why don't you come up to the stage? So I just wanna spend a couple of minutes giving you additional context, right? So everybody on the stage talked about personal AI. But I also want you to think about the fact that every personal tool became transformative because it became social, right? So we used language to coordinate our ideas beyond an immediate group, right? Printing made sure ideas are represented without any bottlenecks. And agents now, all of cognition becomes distributed, right? So just think about the power of social aggregation. My last slide before I yield the stage. So OpenClaw is, the way I think about it, is an operating system for the agentic world. So you're gonna see many examples today in agents reducing personal friction, improving productivity. But to me, the most exciting part is agents actually export cognitive infrastructure, right? So they can carry skills and the scientific process to the entire world. You don't have to be sitting in an ivory tower gated university. Skills-equipped OpenClaw and science claws, as we're going to show you, can be used by anybody, right? So you don't have to be sitting in an ivory tower, be a scientist to do science. And I think that's the spirit in which I want you to think about this. Into the demo. So the demo that Fiona is going to show is incredible in the sense that, you can be a citizen scientist. And earlier, citizen scientist used to mean maybe you count some birds and then you report on a website and, somebody uses that. Right, but now you can do science, right? If you're sitting looking at, an insect wing and you're sitting somewhere thinking about music, Science Claw can actually help port insights from those domains and actually help you build interesting things.
Thank you, Karthik, for the warm introduction, and very glad to be here. My name is Fiona, and I'm supervised by Marcus Buehler at the MIT Laboratory for Atomistic and Molecular Mechanics. And today I'm going to share with you about our recent project on Science Claw and Infinite. Modern science is largely organized around individuals, one researcher, one lab, or one perspective. But the problems we care about today are too complex and interconnected for any single mind to fully navigate. So here we ask a crucial question. What if discovery is driven not by individuals, but by coordinated systems of intelligence? To understand how we get there, it helps to look at how AI is evolving. We've moved from fixed systems that reproduce known patterns to generative models that explore learned spaces, and now to emergent swarms that are systems of interacting agents that adapt and update each other in real time. Unlike earlier systems, these don't just generate outputs. They interact, refine, and collectively shape the direction of exploration. This is where discovery and creativity begin. And this shift mirrors how progress has happened in human history. Our brains haven't fundamentally changed, but our ability to coordinate has. From small groups to large-scale scientific communities, progress came from organizing intelligence across many contributors. The key driver is not just intelligence itself, but how it is structured and connected. And biology provides a clear example. So simple agents like ants, they interact locally, but produce complex global outcomes. They don't have a central controller, and intelligence emerges from their interaction. This becomes our guiding idea. Instead of centralizing reasoning, we distribute it. To bring this idea into scientific discovery, we built a system called ScienceClaw. It breaks scientific reasoning into more than 300 modular skills, from simulation to literature mining to design and structural analysis. These are distributed across a decentralized network of agents, each specialized but able to coordinate with others. Together, they generate hypotheses, test them, and refine them. Because agents can interact, branch, and recombine, discovery becomes a dynamic, evolving process rather than a fixed pipeline. If you want to know more about the technical details of the setup, we can talk afterwards. So once running, the system executes the full discovery loop. Some agents identify patterns across domains, some translate them into design rules, and others generate candidate structures. These are then evaluated and simulated, allowing the agent swarm to explore regions of design space that are difficult to reach through traditional human workflows. We will also show a more detailed demo on the Agentic workflows later. And when we apply this to a very particular problem, which is resonance systems that are structures that control vibration and sound, we map biology, materials, and music into a shared representation, as shown on the left here. This reveals clusters of known designs and regions that are largely unexplored. The system targets one of these gaps, generates a new structure, and validates it through simulation. These types of structures can enable ultra-sensitive sensors, improve medical ultrasound, and more efficient ways to control and direct energy. To make this accessible, we are building the infinite corridor of science. And shown here is a picture of the infinite corridor at my home school, MIT. But Infinite here is a public-facing platform where these investigations are shared and explored. Each result is fully traceable, and you can follow how agents interact, inspect their reasoning, and click into examples to build on top of them. So in this way, science becomes something we can navigate and extend, and not just read. We call this the infinite corridor of science, which is a persistent environment where humans and AI collaborate continuously. The goal is not just faster science, but a new way science is done. If you're interested to explore more, feel free to join the corridor at this website and also scan the QR code, which leads you to the open source GitHub repository of this project. And with that, I will end my presentation here, and thank you for your attention.
Everyone, one more time, one huge hand for Karthik and Fiona for our keynote demo.